Hi everyone, and welcome to this LivFX tutorial on so-called video fixtures. So, what are video fixtures? The most prominent example are the Kino Flo Mimiks. They are not fixtures controlled via DMX, but technically they are big LED tiles controlled via an LED processor. This in turn means we do not send them RGB data via DMX, but we send an actual image to the LED processor to forward to the video fixtures. The mapping inside the LED processor works similar to mapping out an LED wall, just that in this case it's not a wall per se, but rather single tiles scattered around the place to act as stage lights. Now, before we dive into LivFX and how to set this up, let's look at a few possible workflow scenarios. The first example shows LivFX doing the projection mapping for the LED volume as well as image-based lighting. It controls 2 or more processors for the LED volume and 1 processor dedicated to the mimics. In this case, a megapixel Helios processor. Let's look at this workflow in detail. Inside LivFX we have created 2 channels. The first one takes in camera tracking and stage model to calculate the correct projection for the content on the LED volume. When dealing with multiple walls and/or LED processors, we can create a so-called stage mosaic, which is then being sent to all LED processors driving the volume. On the second channel, we do our pixel mapping for the mimics. Same as with DMX-based fixtures, we can position sample boxes of any size on the image content. Now under the hood, LivFX will scale down every however oddly shaped sample box to the actual resolution of a mimic, 120 x 60 pixels. And create a mosaic with all sampled areas nicely lined up and scaled to fit the mimics. This mosaic is then sent to the LED processor where the LED tiles are mapped onto the content. Now of course, not everybody has a spare LED processor for his stage lighting. LivFX can easily combine the fixture mosaic with the stage mosaic in one output to be sent to a single processor that is driving both the mimics and the LED volume or a part thereof. Obviously, LivFX can control common DMX lights as well alongside the video fixtures. You can mix and match as you go. Now for the setup inside LivFX, it's important to know how things are set up on the LED processor side. Let's look at the web interface of our megapixel Helios LED processor. Inside LivFX, we will treat a mimic like a 120 by 60 pixel tile. However, technically, one mimic consists of 2 60 by 60 pixel tiles. That's why we always have to move 2 tiles around here in the LED processor. As you can see, of the incoming UHD signal, we've only mapped the top row of tiles. Behind every pair of 2 tiles is 1 mimic, adding up to 5 mimics overall. Inside LivFX, we can configure our output to match this LED tile layout. Now, let's look at how to do exactly that. I have already loaded a clip that is playing in the background. Here in the fixture stack we can create new video fixtures. Let's create 4 of them and name them accordingly. Let me also add 1 DMX fixture. I'll go with an Airy Sky panel. As you can see, with the Sky panel we can configure DMX universes and channels. However, I can easily turn this one into a video fixture as well by enabling the corresponding button here. This will gray out any DMX configuration parameters since they do not apply anymore. Let me rename the fixture for clarity's sake. Now, let's sample a few areas here in the viewport on the image. As you can see, despite the mimic native resolution of 120 by 60 pixels, I can create sample boxes in any resolution and size. LivFX will up or downscale the sampled image content to the resolution of each mimic. Now of course, we need to link up all these video fixtures with actual tiles on the LED processor. This happens here in the protocol menu, Video Fixtures tab. First, we need to enable the output before we can create tiles to link our virtual video fixtures to. Also, we need to select which output we want to use for our fixture mosaic to be sent to the LED processor. Typically, this would be the dual-head HDMI or an SDI output from our video I/O. For demonstration purposes, I'll use an NDI output here. I'll quickly hit Add 5 times to create 5 tiles to link to our 5 mimics. The first thing to do is to link the tiles to our virtual fixtures, so let me do that real quick. Done. There is a shortcut, however, which I'd like to show you. Let me delete all the tiles and also all the fixtures from the fixture stack and start from scratch. This time I first create my 5 tiles here and now hit the Auto Link Fixtures button here, which will create and link the video fixtures for me in the fixture stack. Nice. As you can see, all of them have the same dimensions of 120 by 60 pixels by default. In case we have video fixtures of a different resolution, we can simply dial that in right here. We can rename our tiles if we want, but for now I'll just leave them as is. Next are the 2 columns for X and Y position on the output. Right now, all tiles would overlay each other at position 0, 0, which is the upper left corner of the frame. We can easily check by hitting the preview button right here. LivFX will jump into dual view mode and show the fixture mosaic on the right side. It currently shows whichever image we are playing out right now, with the fixture mosaic overlaid. For simplicity's sake, let me enable the clean option right here, so the output will only contain the fixture mosaic and nothing else. Let me unlink the 2 views here and zoom in a little. As you can see, right now we're only seeing one tile with 120 by 60 pixels because all of our 5 tiles are at the same position. However, we of course want to spread them out across the frame. We can offset them manually here by moving tile number 2 by 120 pixels on the x-axis. There we go. Or we simply use the auto align option over here and there are our 5 tiles. In our megapixel LED processor, we now need to map the mimics to these positions. If later on we want to swap 2 mimics, we can easily do that from within LivFX. Let's say I want to swap the content of tiles 2 and 3. I can simply do that here by relinking them in the fixture column. Done. And of course, I can still move and scale the sample boxes in the viewport to change what each tile is being fed. As you can see, no matter which way I scale the box or change its aspect, LivFX scales the content down to the tile's resolution of 120 by 60 pixels. Of course, we can control any of these sample boxes via DMX from a lighting console, but this is for another tutorial. Now back to our fixture mosaic. Right now, we're just sending out the content for the mimics to a dedicated Helios LED processor. But what if we only have one LED processor that we'd like to drive not only the mimics, but also the LED volume, or at least part of the LED volume? To make this work, we have to do a little housekeeping. It all depends on the LED wall size, the input resolution of the LED processor, and the resolution and number of our mimics. Our output towards the Helios LED processor has UHD resolution, as we can see here in the monitor's menu. Let's open the Stage Manager from the LivFX menu. In here, we have our stage with the wall we're projecting to. The wall's resolution is slightly smaller than UHD. It uses the width of the UHD output with 3840 pixels completely, but is only 2000 pixels high, effectively leaving us with 160 pixels in height that we can use to place the content for our mimics. Now, to make this a bit more tidy, let me move the output for the LED volume down by 80 pixels. Now we have a strip 160 pixels high at the very top of our output reserved for the mimics, which we're putting next to each other. Since each mimic is only 120 pixels wide, we can place up to 32 of them in one row before we'd have to start a second row. So, there's plenty of room. Going back to our Helios web interface, we of course have to match the layout we did inside the Stage Manager. So here we have the 5 mimics at the top, and below we're mapping all the tiles that are part of our LED wall in order for them to receive their respective content within the UHD frame. Nice. Back to LivFX. If we now disable the clean option and take another look at our preview output, we can see exactly what we've configured inside the Stage Manager. At the top is the content for the mimics, and below the content that goes to the LED wall. Now, before we end this video, I want to quickly show you how you can color grade the content. Of course, like with any fixture, also a video fixture has a dedicated toolset to color grade just that single fixture. But of course, Some color changes would apply to all fixtures instead of a single one. So if the director asks to give the scene a more sunset-like look and we need to dial in some warmer colors, we can do this for the entire image here in the LivFX tab using the color wheels. Or, in fact, any of the grading tools LivFX offers, including layers, keyers, curves, masks, and more. One last thing about color management. With DMX fixtures, we can set a target color space for each fixture here in the Color Transform tab. In this case, LivFX will look at the clip's color space and transfer function and compare it to the fixture's color space and transfer function. And if they differ, do a conversion from one to the other. With video fixtures, this works differently. Since all video fixtures are controlled by an LED processor in a single color space and through a display output, they are also using the color management for the selected fixture mosaic display. In our case, the NDI output we selected here. Now to set things up properly, I need to go to the settings menu and inside to the monitors menu. In here, I can set the target color space for each display output, including our NDI output. The principle underneath is the same. LivFX will compare the color space and transfer function of the underlying clip, to be found here in the media menu, to the one of the display. And if necessary, do a conversion. So if our LED processor and the video fixtures managed by it are working in Rec 2020 and PQ for HDR workflows, we can just tell LivFX here to output this exact configuration through this particular output. This concludes the tutorial on how to set up video fixtures in LivFX. See you next time.